Hello, and welcome to the lesson on the real number system. So we're going to get started by talking about this Let's Explore section. So we're going to take the following numbers, these numbers right here, and we're going to sort them into groups based on patterns or characteristics, and we're going to tell why we put them together. So just at first glance, I would say, and you can have different answers than me, but a couple of things that I'm noticing, right? Immediately, we could probably group these guys together and say that those are square roots. Right? And then maybe we can group these guys together, and we can say that these are fractions. And then maybe we could also group these together and say that they are positive numbers. Right? So just at first glance, these might be the answers that you have come up with, right? And maybe we group, let's see, maybe you went a little bit of a step further and you knew that the ones in blue were called integers, right? So this is just a beginning of the lesson due now. So whatever you have is probably great. And we're going to move on to the real number system so we can talk more about the names for these numbers, right? Because these are not just fractions, they're called other things as well. So a couple of things before we start. The real number system is a system of numbers. And basically, it's all the numbers in the world, but they have different titles, right? They have different titles for things. So we're going to first talk about the definitions of these different numbers. So first thing we're going to talk about is rational numbers. So rational numbers, I'm going to write some notes and you can copy them in. Rational numbers are numbers that can be written as decimals that end. This is very important. They can be written as fractions. And rational numbers are positive and negative. Okay, so that's what a rational number is. An integer is a whole number, so no decimals. Right? Integers are whole numbers. And they are also positive or negative. Okay, so when we talk about integers, we're talking about -3, -2, -1, 0, 1, 2, so on and so forth. Okay, so that is what an integer is. And as we go through this, you can see if there's anything that you recognize that you might have done before this. Okay, now we're going to talk about whole numbers. Whole numbers are numbers without a fraction. So they're numbers that can be simplified. And I'm hesitant to use the word fraction because whole numbers can be disguised as fractions. So when we talk about whole numbers, we're going to say whole numbers are only positive. Whole numbers include 0. That's very important. And whole numbers is a number, I'm going to phrase this very carefully, a number that is not a fraction. But we're going to come back to this because, again, like I said, whole numbers can be disguised as fractions, okay? And we're going to talk about that in a minute. And then we have something called a natural number. A natural number is a positive only. It is a whole number. Right? So no decimals, no fractions, unless it's under disguise. And it does not include 0. So what does that mean? Natural numbers start at 1 and they go up. You also can think of natural numbers as a counting number. So if you're counting something, like a number of trucks, for example, you wouldn't count 0 trucks, right? You'd start at 1 truck, 2 trucks, and you can't count negative trucks either. Let's talk about irrational numbers. So as you can probably see, the irrational numbers is completely separate from this whole box, right? You see the little space between them right here. There's separation. Irrational numbers are numbers that are decimals, that have no ending or pattern, okay? They are not fractions, okay? So if it's a fraction, it automatically cannot be irrational. And they go on infinitely, okay? So they're infinite. But a really important part about being an irrational number is that they don't have a pattern, okay? No patterns. Common irrational numbers are non-perfect squares. So non-perfect roots, right? Radical 2, radical 3, radical 5, right? We're skipping radical 4 because the square root of 4 is 2. And then another type of irrational number that is going to come up is pi. You probably have all heard of pi, right? It's around 3.14159, dot, dot, dot. No pattern, no way to predict the next number of pi. So what we're going to do now is we're going to take our definitions and we're going to fill in these answers, these questions right here. So we have a little key so that we can fit everything, right? So R is for rational number. We're going to use R for rational. We're going to use I for integer, W for whole number, N for natural number, and IN for irrational number. Now, numbers can be more than one type of number. We're going to start with number 5. Is 5 a rational number? Yes, 5 is a rational number because it's a decimal that ends, right? There's not a decimal, but we could make it into a decimal, right? 5.0. So that is definitely a rational number. Is 5 an integer? Yes, 5 is an integer. It's a whole number that can be positive or negative, right? So 5 is also an integer. Is 5 a whole number? Yes, because 5 is positive, and it's just a number that's not a fraction, right? So 5 is a whole number. And is 5 a counting number or a natural number? Yes, 5 is also a natural number. So 5 is all of those things. It's just not irrational. What about the number -3? So -3 is a rational number. It is also an integer, right? Let's go back up. Integers can be positive or negative whole numbers, okay? Is it a whole number? No, it's not a whole number. Why is -3 not whole? Because whole numbers are only positive. So we're going to stop there. What about, let's erase my little comma. Okay, what about 1/2? So we know fractions are always rational. Now we're going to go down in the chain. Is it an integer? No. 1/2 is not an integer because integers are only whole numbers, right? They're only numbers without decimals or fractions. So we stop there. What about -0.4? So we know that decimals that end, 0.4 is an ending decimal, are rational. But again, we stop there because 0.4, once we get after rational, all these numbers here can't be decimals or fractions, right? Integers, whole numbers, and natural numbers don't include decimals. So therefore, we can stop right after rational. What about radical 9? So here's a little trick, right? Radical 9 is really what? The number 3. Radical 9 is disguised as the number 3 because the square root of 9 is 3. So now when we're thinking about what 3 is, we're going to think of 3 as radical 9 is 3. So 3 is rational, it's an integer, it is whole, and it is natural. Okay, what about radical 10? Radical 10 is not a perfect square. Immediately, non-perfect squares are irrational numbers. Once a number is irrational, it cannot be anything else, okay? 1.234 is a decimal. Does it end? Yes, which means it is rational. But that's all it is. It's not an integer, it's not whole, and it's not natural. What about the number 0? So 0 is definitely rational. It's definitely an integer. It is a whole number, but let's go back to our definition between whole and natural number, because whole numbers and natural numbers are exactly the same, except for the number 0. Whole numbers include 0. Natural numbers do not. So 0 is rational, integer, whole, not natural. What about -2/3? -2/3 is rational. 9 is going to be the same idea as 5, right? Because it's a number, a whole number, right? So it's rational, it is an integer, it is positive, so it's whole, and it is a counting number. All right, 1.564267759 dot dot dot. This number, you can't predict that next number. We have no idea what it's going to be. It's a number that goes on forever without a pattern. Irrational number. Radical 2, which we conveniently spoke about up here, again, a non-perfect square. And then again, once you identify a number as irrational, you cannot identify it as anything else. 20 over 4, here is our disguise that I was talking about. 20 over 4 is really what? 20 divided by 4 is really 5. Tricky. So, we're not looking at it as a fraction, we're looking at it as a number 5. So 5 is, we already actually have that in number 1, so we know it's rational, integer, whole, and natural. And then negative 9, right? Rational and integer. It's not whole because whole numbers have to be positive. So now we're going to try some true or false questions. That could be either, right? Some of them are a little tricky. So let's identify this one. A number can be rational and irrational. No, cannot. The number 1 is a rational number, integer, whole number, and natural. So is it rational? Yes. Is it an integer? Yes. Is it whole? Yes, because it's positive and it can be counted. So yes, this is true. 0.13 is an irrational number. No. Why? Because this decimal ends. Rational numbers may include decimals. That is true. As long as the decimal ends, that number will be rational. A number can be a natural number and a whole number. Yes, that is also true. The only number that can't be both is 0. But every other number is either between whole and natural are the same category. They overlap. Every integer is a rational number. So this is an interesting one. So yes, every integer, this is true. And let's talk about it. Every integer is a whole number, right? It's a whole number, positive or negative. That means that every integer can be classified as a rational number because rational numbers include integers, whole numbers, and natural numbers. Rational numbers include, I'm going to say that one more time because that's really important to help you understand the connection. Rational numbers include integers, whole numbers, and natural numbers. All irrational numbers are real, yes, because this whole system right here is the real number system. These are all real numbers. When you get a little bit more into math, you'll learn about non-real numbers or imaginary numbers. The number -5 is a whole number. No, right? -5 can't be a whole number because whole numbers are only positive. Every real number is either rational or irrational. That is true. The number pi is a rational number. No. Pi is an irrational number because it goes on and on forever without a pattern. So the number pi is rational? No. You would use natural numbers to count toys. Yeah, right? Natural numbers to count toys. One truck, 2 trucks, 3 trucks. Toys can't be negative. Toys can't be fractions unless you break it. Then I guess you could have a half of a truck. You could use integers to count how many students are in this class. So this is one of those tricky ones, right? That I could, if you argue your point, I could definitely see either way. You could use integers to count how many students. True, right? If positive, right? Because we can't use, we don't have negative students. Or you could say false because integers can be negative, right? So either way, I would give you credit for either of those. Fractions can be whole numbers. Good question, right? Again, I could see either way, but I'm going to say true, and I might give an example. We can use 20 over 4. We can make up our own, 9 over 3, right? 9 over 3 is a fraction, but it's also equal to 3, which is a whole number. And then decimals can be whole numbers. No, that can't be true. Decimals are parts of a whole. Okay, so that was the entire lesson on the real number system. Hope it was helpful, and I will see you in the next one.